Okay, so today we're not just learning about texture instruments, we're not just learning about LaunchPad, but we will make ourselves some musical instruments. And in order to make music, right, we'll need a little help from a friend of the LaunchPad, and that is the Educational BoosterPack. So we talked about earlier what a BoosterPack is. A BoosterPack is something, it's like a little additional tools that you can add onto your LaunchPad to make it more powerful, right? You can add things like display or light or sensor. So the Educational BoosterPack that each one of you also has on your desk has a lot of components and cool stuff that that the LaunchPad can control and do cool stuff with it. We have a display screen up here. We have a buzzer that we will use in this project, and we have a bunch of other cool components that we will use in the next couple of projects. For this project, we will use two things. So feel free to take it out of the box, the white box, and you might be able to notice on the board, on that booster pack, there are two components that we will be using for this lab. And the first one is a potentiometer, and that's a little thin wheel that allows you to kind of scroll up and down, just like a volume knob. On the other side, we have a buzzer. So the buzzer is something that makes a sound. It can actually make any kind of sound at any frequency. So the microcontroller can tell it, hey, make me a pitch at 400 hertz, and the buzzer will make a sound at exactly 400 hertz. So what we will do today is that we will read the input from the potentiometer, and when you scroll the wheel, you're actually changing it up or down or lower or higher. And based on that scrolling wheel motion, the LaunchPad can read that in and tell the buzzer to make a pitch or a sound based on your input. And based on that, we can make our own musical instrument. So just a really quick thing, earlier Adrian mentioned the microcontroller looks like the chip with about 20 legs coming out on both sides. So what is also important is that we need to find out what pins or what legs are connected to these components. So this map, it just gives you a quick overview of what the components, or which pins the components are connected to. So our potentiometer is connected to pin number 5, or it is also known as A3. And you will see this again in the code later in our sketch. And this is how you know that Energia is telling the microcontroller, hey, read the input from channel A3. On the other side, for the output side, we have the buzzer connected to pin number 19. And that is the pin that you will also see in the code in the sketch, where the microcontroller is told that, hey, make a sound on pin number 19. All right, so the only hardware change that we have to do is make sure that jumper is in the right position. So the jumper or the header is this little black thingy that is now connected to a few exposed pins on top of the booster pack. So what you want to do there is to make sure that the black jumper is properly on top, and then there should be 2 pins by themselves, and then there should be so all you have to do is just move the top jumper or the top black header, this guy right here, unplug it, and then plug it onto the top position. So what it does is, as we will learn later on, these 3 pins are all connected to our potentiometer, but it's also connected to another component that we will be using later on. So for this lab, we want to connect it to a potentiometer, and that's why we have it put it on top. For another lab, we might have to put it on the bottom. So as similar to before, go ahead and try to find our sketch. So just follow this trail, file, examples, 0 educational BP, and now we're going to chapter 9 and project number 19. Musical instruments. There are a lot of musical examples in that chapter, so be careful. Make sure you select the musical instrument sketch. Is everybody there? Now you should see yet another new window open up with new code, right? So let's go through the code really quickly. You see that this code is quite long, but as a matter of fact, most of the code is actually just green lines, right? As Adrian mentioned before, those are just comments. Those are just what try to explain and helps you, reminds you of what's going on. So in reality, the main code there are only 3 lines of code that you really have to look into it to figure out what's going on. And that's all you need to read the information from the potentiometer, process it, and then make music out of it. So let's go line by line. So this is the first line where you can read out. You are pointing analog read from the channel number A3, and you read that value and you store it into sensor reading. So what does it mean? What it means is that by scrolling that little wheel, you're actually changing the value on that sensor, and that value is being read into the microcontroller brain through the analog read function, and the result is stored inside sensor reading. So now sensor reading is the value or the guide that we know what the value was on the potentiometer. Second line, this is where the brain is at work. This is where the brain processes this information inside sensor reading and determines what kind of pitch should I make out of this input. And that's where the magic happens. And as a result, it produces this pitch. And this pitch is actually the frequency of the sound of the note that it's going to tell the buzzer to make. And it's doing that in the last line. Really simple. All it does is make a tone on pin number 19 of the frequency of stored in this pitch, and make that tone last for 100 milliseconds. So really simple, right? 3 lines and 3 simple functions, and now you can make your own instrument. So let's give it a try, shall we? At this point, you can click on that upload button again, and let's see if we can make some music.
Oh, let's make sure the booster packs are plugged into the LaunchPad as well. So it just stacks on top. So remember, these are plug-in modules. So just make sure all of the pins are connected. And if you just plug it in,
if you can
there you go.
Plug in the other way around. Yes,
right
that's
top.
Right.
Rotate it. There you go, if you rotate
yep, you have it right. Just push it all the way
like
down.
That, and then just plug it right in. So be sure to try to turn it to see what happens on the sound side. There you go. Oh, it's this guy right here.
All right, so if you want to stop the music, what we can do is just unplug the LaunchPad from the USB cable. You can resume this at home at any time. So let's pause with the music for a while. All right. Oh, I feel peace, so much peace. So what did we learn in this really short lab? I mean, we learned a lot of concepts, right? We actually, first and foremost, most importantly, we learned how to make music. And this is actually how a lot of musical instruments are made, with just maybe a little bit more intelligence in there. But the key concept is the same, right? You have some input. It could be like a keyboard, and you just press it on the keys. And the brain inside the keyboard controller will decipher that. It's like, oh, you press on this C4 note, so I need to make this frequency of this, 400 hertz, for example. And that's how tones are being made. We learned about inputs and outputs. And we have already used input and outputs for a couple of times already, but the key concept of any microcontroller application or anything that you will ever make is there's input and there's output. As long as you identify what are your inputs, and you figure out how to read that input in, and you figure out how to process the input, and then the last step is figure out what are your outputs, what are the things that you want to express to the world, whether it's light, whether it's display, whether it's messages or wireless. Once you figure out the inputs and outputs, you can kind of create any application you want. And the last but not least, we learned a couple of functions. These will be helpful later on if you want to do your own projects. So these are the analog read, which allows you to read in any analog signal, and tone, which allows you to make music. So there are a few other musical examples that you can do. Feel free to give it a try. If you know the notes to the song, right, you can make your own song. So instead of using the scroll wheel to figure out what notes you're and turn it into a musical instrument, you can actually tell the microcontroller to play a song. So by putting all the notes in, you can actually make a tune like birthday music or like a Star Wars theme. So give it a try. And so all of these examples are also already in Energia. You just have to follow the same path again and go to chapter 9. And there are a few examples of other musical projects that you can open up. All right, so our challenge to you out of this exercise is when you get home, Try to find your favorite tune, try to find your favorite piece of music, and then find all the notes and try to compile that list of notes and put it into LaunchPad and make your own song. How cool would that be?